Okay, good morning, everyone. Thanks for coming. We at Dark Belly International appreciate your attendance. We know you have many choices at RSA, but on a serious note, we're here to talk about the dark belly of corporate data access. And I'm Jenko Wong. I work on the threat research team at Netskope. And dark bellies, as a general term, are about hidden, illicit, maybe vulnerable things, bad, nefarious. Much like, in case you didn't know, SeaWorld did shut down their orca show, but it really was the Bellagio that kidnapped those orcas to, have their nice, pretty fountains. For our purposes, though, we're going to talk about OAuth application access to corporate data. And so if this presentation were a movie, I want to sort of give you a heads up of what the plot will be, right? Just want to be transparent so you know what's coming, as well as how your sort of emotional state might be, right? So we're going to start out hopefully with some definitions, some concepts, because some things will be different with this cloud world that includes OAuth, right? So we'll probably start off on a high note, be all excited. We'll really look at, is this really a problem, right? But to help that along, we really want to start looking at data. So I have some data from production environments that hopefully will bring this to real life. And part of the key here is this really a problem, right? There's a lot of hypotheticals in our world of cybersecurity. And probably more importantly, is this your problem, right? Much like the joke about you and your friend running from the alligator. That's a real problem. Someone's probably going to be eaten. But it's not really your problem if you run faster than your friend, right? So that's important. We're going to go through this, and I want you to sort of map it to your environment, what you know, what you do in your day job. And that's sort of where we'll hopefully develop a lot of character. It's going to take some thinking. And unfortunately, there's going to be some conflict. And so we're probably going to sort of have some despair moments. And I'm going to make a confession, if I can pause here. Most days I just wake up and just hate my job, want to quit. I mean, this has been 20 years, right? And I know you know what I mean. It's because we're in an industry where the problems are too theoretical to most people, right? They don't understand them. It's too technical. It feels like you're selling insurance to someone who doesn't want it. And then by the time something happens, like a disaster, ransomware, whatever, user printing checks at home, it's too late. They're now convinced, but they probably lost all their money because of paying off the ransomware. So it's a tough business where you're sort of fighting that. And as you can sort of see, there's a little bounce at the bottom, right? We're going to think we're recovering, and then we're going to sort of be in despair again. Yes, this is also like our stock market, S&P 500 index, right? And at some point, we hope people be quiet and we focus on some solutions, and we'll get some hope. We'll talk about maybe some of the things we can do, security controls included, to make this problem go away. Which is a lie, because, right, in the business, we're never perfect, risk doesn't go away. But hopefully we can contain it, shrink it, and see where we end up. And hopefully there'll be some resolution. Remember the good old days? The world used to be simple. I know it's hard to remember, but we actually used to have networks that we controlled. Perimeter firewalls, layers of defense. It was great because if you're in the business of defending those networks, you had a centralized IT or security operation. You ruled with an iron fist, right? It was great. Whatever it was, your users actually opened up tickets, had to come to you, begging for access, and you would write it down and you would know everything, from firewall rules to database access to even remote connectivity. There's a few blips in there, right? I know this is hard to remember because it's been probably a few years, right? There was rogue Wi-Fi devices, network access control with people hooking up their laptops, bring your own devices, but we beat that down, right? Things were in control. Then it's turned a bit cloudy, right? Dark clouds, this cloud architecture, which has been 20 years in the making, has become really popular. So now a lot of data, a lot of apps are running in the cloud on someone else's network. SaaS providers, cloud environments. And unfortunately, one of the things that's happened, but I think it's been a little bit sneaky, is there's been a different model to grant access to that data. And it's user-driven. That's what I call a user model. It's OAuth. So by default, users are allowed to grant and give various permissions, subsets of what their permissions are, to third-party apps. So what's an example? Your resources might be as simple as something like files stored in Azure or Google Drive. Users can grant access to anything from Slack, or there's a gajillion, right? Gajillion apps that might want access to read or write data on a data storage area. And the problem is, the result is this mess. All those colored lines, literally thousands and thousands of access paths. Now you can think of this as a delegated access model. In the old days, users would hard code passwords. Something as simple as a mobile client, a mail client. Type in a password and it'd be stuck there. Bad model, hard to change, hard to manage. And we moved to this model where instead the user can log in to Google or Microsoft or wherever their mail provider is. And there's be these tokens passed around. And you'd have all these hidden kind of paths, right? You feel good that there's no hard-coded passwords, but you still have all these access paths that you may not be aware of. And that's the whole point of this talk. So let's start moving into trying to answer the question, is this really relevant, right? You get the bigger picture, I hope. Is this really relevant? So I want to look at some data. I'm going to start with what I'll call OAuth approval data. It's the action of a user approving a third-party access, giving some part of their credential with access to some of their data. And it could be Google resources like Google Drive or Mail or even Google Cloud, Microsoft, very similar in services, but we'll focus on Google data for this presentation. But it could also be other big SaaS ecosystems. What do I mean by that? It is true that most, probably 99% of organizations use Google or Microsoft, but you could have a file share, a corporate Box account that could be just as important and holding crucial data. That becomes another area that could have these access paths. CRM, Salesforce, et cetera, or cloud environment. Most of them speak OAuth, and users will have this ability to grant paths. So what is an OAuth approval? The consumer version, you go to a website, you check out with PayPal. There's OAuth in between. We've probably seen the corporate version, enterprise version, but I want to give a little bit different example. There's command line utilities, a technical administrator example. So if I use Google Cloud's command line, I can say, as a user, I want to give it access to what I can see and do in Google Cloud. And I can do a command line. And it will open up a browser, if it can, on the machine I'm running this command line, and start to prompt me to authenticate. Google does a lot of caching, but you can see that if it were a new session, I would go through username, password, multi-factor. Here I'll select Joe Blogs, the second one. And then I will get this OAuth approval dialog. It's not really called that. You can look at it. And what we see here is something that lies between the spectrum of certificate padlock information in your browser and a EULA license in terms of complexity. It's not as simple as a padlock icon, which no one clicks on to check certificate information, and it's not as complicated as EULA, but the common thread is no one understands it, and they're just going to hit OK and allow, right? If your eyesight is good enough to see the 2-point font, you will see some permissions. You'll see a few things. Google Cloud SDK wants to do something. This is the user that's seeing this. Right after they logged in, and you're being asked for certain permissions. What is Google Cloud SDK? It's a name that the developer of the app chose for their app. Well, I started the CLI. Yes, I'm an administrator, I may know this, but Google is the developer of the third-party app, the CLI, that's asking for this. They named it Google Cloud SDK because the CLI comes with SDK. However, this poses a problem. How are you supposed to know what's being asked of you? There's an almost arbitrary name. In this case, it doesn't even match what I think about. I think about a CLI. Why are you saying SDK? There's a bunch of permissions defined by Google. You may or may not understand them. And then you hit OK. As soon as you hit OK, you get a little confirmation message. Now it says gcloud CLI. It said SDK in the one before. And the CLI continues on and says you're logged in. And now I can do CLI commands. That's the third-party app. Magically, underneath OAuth, Google Identity has created a token saying this user authenticated properly. They said OK. There's a bunch of permissions. Here, app, here's the token. Go use it for API calls. OK, that's how OAuth works. We're going to look at that data. We're going to look across sort of anonymized data from lots of production environments. OK? And then, just to be clear on how you get this data, because ultimately, if this is useful, I want you to go off and think about looking at your own environments. The identity provider, Google in this case, but could be Azure, Microsoft, Salesforce will have their own APIs. They have APIs to usually what's called an audit log, sometimes an OAuth token log. There's APIs and console features to get at events. Oh, this user approved this app with these permissions. You get an entry. That's what you want to collect, and that's what I'll go over. And it looks like this. This is Google's version, Google Workspace Admin Console, where the identity is managed. If you go in there in reports, you can find an OAuth token log. I know it's hard to see, but in the PDF, if you look at the presentation, you can zoom in. The key thing here is to know what level of detail is actually audited, right? We can only see what's actually collected and given to us. You've got about 12 fields on that right box. I will name the key ones. You get this application ID. It's created by Google when the developer of the app creates it. It's just a unique ID. You get a name, which the developer sets, right? Could be Google Cloud SDK. It could be O365, right? Abuse can happen because app identity is shaky. I'm giving you a little warning. How do you know the app is the app? You've got a name chosen by the developer, and you've got a meaningless, unique ID. It's a warning, okay? App identity is tough in this world, but we can still do some analysis. You get the source IP, which is usually where the app's public IP address is at the time it grabs that token after the user hits OK and allow. You don't get much else. You do get the username, and you do get the permissions. Permissions are called scopes. They are URIs, sort of HTTP type things, defined by Google or whoever's the resource owner, okay? 12 fields. Not a ton. That's what we're talking about. In the console, the easiest way to get started, if you're new to this area and you find this valuable, go to the console. You can export it, CSV, low tech, first step. You don't have to be fancy. You don't have to program. Don't have to throw those stuff into a database. You, of course, can feel free to certainly go against APIs. Everything has an API, including the audit logs, right? And so I can write, which I did, a simple little program that prompts the user for permissions, someone who has access to the audit logs, like an administrator, to log in, and then I can go grab in JSON on the right a whole bunch, those same fields we just saw in the GUI. Just saying it's possible, but the lowest barrier is to use the console. So is this really a problem? Let's start looking at some data. So in this connected app world, we have apps, we have users who give them access with permissions. Let's start with apps, right? Especially if you're new to the area and looking at your environment. Just start counting. Let's not get fancy. Count how many apps are connected by users in your environment by looking through the audit logs. So in some of the big data sets, I just pulled out a few numbers. Things that may surprise you or not. So for across millions of users that were granting permission to apps to their Google environments, which includes Google Drive, Google Apps, Google Cloud, we had over 400 unique apps. Now, I want to pause there. There's not context around that. You don't know how many users, okay? You're not quite sure of the permissions. But I just want you to internally think about, is 440 higher or lower than what you would expect? To me, it's higher. Why? Because naively, when I come into this, I'm thinking, well, what do I expect to find? 25, 50 corporate apps like Office and Google's App Suite and Zoom. I can't think of more than 25, frankly. Maybe you have more, 50. Okay, then there are specialized apps that users, let's double it, 100. Okay, I missed it. I don't get to 400. Now, I'm not saying that's alarm bells. I'm saying somewhere in your heads is a number if you had to guess. And the first thing you'll do in the first 5 minutes is see if, is it close or am I off? Because if that number is really low and it's 2, then you go play golf and you tell your boss everything's under control, right? So good news, right? Even if you're one of the 1%, this is still good news. So counting without context still is helpful to get a quick assessment. I looked at different slices. I looked at, hey, what about organizations 500 above? Let's take out the really small organizations in case they skew the data. Even then, the average was 250 and above. Still a higher number than I would expect, me, Jenko. The worst offender in my data set had over 12,000, 12,330. You're asking, what's the context? Context is they have a lot of users, 100,000 plus. Very, very large enterprise. I will grant you that. The thing is, as a security person, that ratio, even if it's 1 app to 8 users, seems okay. It doesn't make you feel good because those 12,000 apps are going to make work for you no matter what. If you had an incident, if you're explaining under audit all of the access paths, you have to justify 12,000. Do you know what those 12,000 are? And then you'd be like, no, but it's a good ratio. We have lots of users. No, it doesn't hold up if you think about it. It's going to cause you work. So the point is, no matter how big you are, if the absolute number of apps is too high than your reasonable threshold, you're in trouble if you don't know what that risk is. Now, if you do know and you say, no, those are 12,000 absolute must-have apps, okay, maybe you can move forward on that. Here's a different look at apps. I took a look at larger groupings and enterprises, over 5,000 users. I just focused on, let's just focus on apps that want to access Google Drive in any way, any kind of permission. And I know there's a lot of data. Just focus on apps and users. I want to talk about app counts, really, really basic stuff. I just gave you sort of the top 20 organizations with sort of app to user ratios. And I just want you to think about, hey, would that number cause me for concern? If I'm running an organization that has the first line, 10,000 users and 1,200 apps, how do I feel as a security person? How about 35,000 users, 2,600 apps? I will guess that any number above 1,000 probably causes your stomach to churn a little bit. And you're like, oh, that bagel I ate this morning, right? Because there's work. No matter what, there's work there to assess the risk. Now, the double digits, under 100, makes you feel good. At least it makes me feel good. Look at the last line. I got 7,481 users, but I only have 53 apps. Oh, that makes sense. Corporate apps, whatever's in there. My next hour of analysis. This is a manageable problem. So the whole point of this is start simple, just count, see what strikes you as an outlier. Of course, we're going to want to get into detail. So underneath this is specifics of which app. So just to give an example, the table on the left is more a summary of some of the raw data grouped by the app name. But I pulled out in the middle stuff so you could see it a little bit better. What you might find is a lot of usual suspects. This is sort of like the top-end look of what users have granted access to. So you might see things like Google Chrome in there, iOS, Atlassian being a Jira product, things that you could think of Adobe and Zoom that might be part of an approved corporate standard. You're not too worried. You're like, of course it makes sense. A lot of users are saying okay because that's what we use. Some things might cause you a question mark. Android device? I mean, not the beacon, shining beacon of security, right? So you might wonder what on Android on the phone. Maybe it's Gmail, maybe it's something else. At the bottom are things that might strike you as unexpected, or at least you want to focus on. Pinterest, consumer type stuff. New York Times, why does New York Times need access to a Google Drive? It asked for it, the user approved it. It's in our data, so on. So Postman stands out. Postman, if you haven't used it, technical tool, I classify it as a security tool, but you can make API calls, REST API calls, modify it, play around with it. I would expect a security or team to use it, maybe an IT team. I would want to look at that, especially since this is all about access to Google Drive. Why does it need to have access to Google Drive? I can see us using it, but why is it asking and why did a user approve it? Okay, there are different app categories that may be helpful to assess this first look at information. So loosely put, a lot of Office and collaboration makes up almost 50%. You'd expect that, people using Office type apps. But then there's technical tools, security, backup, and migration that add up to about 15%. Does this make sense? Probably does. But just note that both ask for a lot of permissions. And that's why they're pretty popular. Backup, you usually need access to a lot of things, the whole Google Drive. A lot of Office products would make sense. So how do we understand what permissions there are? It all goes back to the identity provider, the resource owner, Google in this case. Their documentation has a list of over 250 permissions grouped into sort of API categories, about 140, 150. It's a lot of different permissions apps can ask for. Mostly the explanations are reasonable, but you have to do some work to actually understand what some of these are. So if I looked at the most popular individual permissions granted in my data set, or you do as you go through, you see there are a couple themes. So this was actually a focus on update permissions, so that's why you see the keyword manage in a lot of these. But you see Google Drive right at the top. Read-write access basically to everything in the user's Google Drive. That's what was granted and asked for by an app. You see email in there. You see spreadsheets. Spreadsheets are a super popular app category. Everyone's got a utility to manage your Google Sheets on your drive, and they want access to everything because it's a common file format. Then you get things that are popular, but talk about provisioning users in the domain, and that's something that should catch your eye. So you could query your data and see what's popular. And I'm telling you, at a global scale, we find things like this. I want to give you a framework for maybe thinking about permissions a little bit better so we can get into some of the risk analysis. So, apologize, this is small, but this is like a quadrant, magic quadrant, if you will. Users, few to many on the bottom, and categorizing these multiple hundreds of permissions into categories of scopes. From the bottom, an app could ask for a very narrow permission. As an example, an app might just say, I only want to read and write the data I create, this app. That's like a little sandbox. You feel safe. You can generally ignore those because those are sort of very restricted permissions. But then there are overly permissive type scopes, as we call it. That could be the number, it could be read-write, it could be a whole bunch of things that make it more sensitive, right? Then there are admin type level privileges, or all files of a certain type. And then there is usually an Uber category where it's asking for basically everything. Now, why would this be useful? Why am I raising this? Because when you look at your data, you don't want to split things into 200 different permissions. It's just too granular. I would suggest you look at categories, because then you can see apps that are asking for admin type level permissions. Yeah, there's 30 of them in there, but this category is something I need to focus on, right? So how do we sort of get at this? Well, I'm telling you, in the real world, when I look at the data sets, there are the high majority of apps ask for all types of file types of a certain kind, like all spreadsheets. It's very, very popular. But right behind it are elevated or escalated type permissions, two categories. Sensitive data, which might include things like health data, classroom education, sort of student data, all data on Google Drive. Those are the orange and whatever teal middle bars. They add up to about 45%. It's very common for sort of these sensitive permissions to be asked. The most restricted one, only the application data is only 1%. I'm saying in the real world, what users approve sort of falls in this pattern. The question is, what will you find or what do you know about your users? Does it match up with this? Basically saying apps tend to ask for a lot, users tend to say okay. That's what we're looking at. So let's talk about some of these categories. So as an example, when I took 2 of the categories, any apps that ask for all access to Google Drive or sensitive data, those are categories that I defined out of the couple hundred. I grouped them into the more sensitive scope. I found almost half of apps asked for that, right? 44%. And of that 44%, 17 were focused on all data on user on the Google Drive, right? Again, these numbers have to have some context. It's most meaningful in your area. I'm telling you, in the real world, apps ask for a lot, users approve them. And if you don't know that and accept it, that's one of your first steps. So going into the categories again, view and manage all spreadsheets on your Google Drive is an example. You can look at the data, and you can look at which apps are actually asking for that elevated privilege, and you can see if you're comfortable or whether you need to address that. Weed out those apps, focus on users approving those apps. And so when I did it across this big data set, a couple things jumped out, which I highlighted in red. DoorDash, why does that need access to all spreadsheets? It could be, I'm not saying it is, it could be the driver version of DoorDash, which does accounting and tracking of time. That's my way to give a pass, but I'd have to investigate it. The consumer version for ordering food to be delivered, why does that need access to sheets on Google? Doesn't make sense. Needs investigation. Untitled project. By default, if you create an app on your own or your user does, you often get default names. This shouldn't be allowed, right? If it's allowed, name it. If it's not, let's get rid of it, right? Tells us nothing. Zapier, I only flag because there are integration products out there that love to connect apps and have you do workflow. If this happens on my Google Drive, upload it to my OneDrive. It's like if this, then that on the consumer side. The problem is it speaks OAuth and it becomes a connection point. So if I see that, I'm worried. It's a portal that the user's using to tie a whole bunch of stuff that I don't have visibility into my environment. Quick start, remove duplicates. Quick start might be a tutorial, have to investigate that. Remove duplicates, what is that? Is that a custom app, is that right? So we could go on and on. Untitled project pops up when I look at apps that are asking for write access to email. Fitness, health information, classroom information. I can see that there's only a small number of users because this was hundreds of thousands of users on this slide, but it's really sensitive data. So the number of users isn't only what I focus on, the sensitivity is what I look at as well. Okay, one of the worst, no, let me put it differently. From a permission perspective, one of the worst things that came up in the data set was, geez, there's this one app in only one organization. So very, very small users, but the list of permissions was like domain-wide. If you look at this, it includes access permission to everything in domain or delegating admin roles, a lot of for domain, and in the Google world, that's pretty broad. App licensing, audit reports, cloud storage, and buckets. By its name and the fact that it was only in one, it seemed like a security tool, an in-house built security tool, which could be perfectly allowable. The question is, was it on your list or not? Hey, our security team was developing this. Hey, our IT team was doing this. Hey, a random technical user was doing this. It would be ask, verify, and then decide, you allow it, but at least you know now that this tool, has this privilege. And it was named to be an alerting tool, so you might still ask, why does an alerting tool need to do provisioning of users, right? Let's be clear on not over-privileging access, right? You would apply all the things we do in security. So, how bad can this all be? We're talking about things that hit your gut. Well, another thing that came up in pouring through the data, just reviewing what had rewrite access to all of Google Drive, but a small number of users, was this app called Cam Scanner. Only used by, out of 500,000 users in this data set that I was looking at, only by, small number, 200, which is a very small percentage. But so what tickled the eye, sort of the eye was, well, what is this cam scanner app? Is it really image editing? And with a little research, you find that it was delivering malware at some point a few years back. And that the Indian government also, around the same time, shortly after, banned it. A lot of smoke. Now, could it have been fixed? Is it, there's still a bad company, bad app? Maybe, maybe not. But you're certainly going to put it to the side, contain it, do an assessment. Right? I mean, it's true that SolarWinds might have fixed their stuff, but you might be dubious about using them in the future, right? At some point, a few years down the line, people will ask the same thing. And you want to know if they changed their name or the product name and so on, right? You're going to want to do that. So how do we take all of that and turn it into maybe an approach you could use when you go look at your audit logs? Or if you've already done that and you're ahead of the curve, how you can maybe extend it to get more value out of it. So I'm going to propose in sort of double quotes a little F framework. I don't want to throw sort of big buzzwords and make it more than it is, but it's something that's helped me sort of get and organize a lot of this. So it's just not disparate checklists of stuff, which just comes and goes, right? I tell you, do 3 things today, and then next year it's 4 other things, and you're not sure if you're making headwinds. So one thing you can do is map and think about existing risk concepts. Because at the end, you're going to be measuring risk and trying to reduce it and control it. So there are terms we use. In the vulnerability management space, we have scoring with CVSS, and a lot of that's based on, hey, risk breaks up into these big categories of impact and vulnerability and attack factors. That'll be helpful for us organizing OAuth-related risk. Why? Because then you can sort of go along the lines and say, hey, this number, this risky app is going to cause bigger impact because of this. And I have well-known techniques and controls that are going to help reduce it. You can just organize your whole approach. If we use another buzzword like attack surface, that does have relevance here. It's in the vulnerability area. So let me give you an example. Because you have a ton of apps approved by users, how does that affect your risk? Well, I could say it increases the threat part of your risk because there are specific OAuth attacks based on individual apps. Like as an example, the usual suspects, Microsoft Office apps, OAuth apps, are spoofed in a phishing manner. And so if you have more and more apps being granted, the likelihood is that you may have more attacks because of the apps that you normally are approving in your organization. But scopes and permissions might affect a different area. So if a user is granting sensitive permissions like all data in Google Drive, that sort of affects the impact. Because once there's compromise or loss of data, it's a lot of data or sensitive data. So this is useful there. Remember the data. We're starting with the audit logs and the approvals. But there's more that will be useful. This is sort of the second step. It doesn't have to stop you from getting started. But not all users are the same. So think about that. If they do the same exact thing, user A grants 100 risky apps access to their whatever Google Drive. User B does the same thing. The risk is different, solely based on the users being different. One's the CEO, one's whatever, someone who doesn't have a lot of sensitive data on their Google Drive. So the second piece of data that you keep in mind in this framework is, probably as a second stage, get user and group role information. Dump it from your directory. So if you're a Google customer, Microsoft customer, go to Azure AD, go to Google Workspace, and dump the groups and roles. Because if you're organized, that might reflect their job function. Oh, this is a finance person. So their Google Drive might have a lot of financial spreadsheets versus this other person who probably doesn't have anything there. But it's a nuance that I need to point out here. I should have called it out better in the slide. It's not just the identity groups and roles. Think about Google Cloud or Azure Cloud. The groups and roles are not in the directory side, they're in the cloud side. So you might have to dump from a different source. What I mean is, how do I know you are an administrator in Google Cloud versus you who have just access to one bucket in Google Cloud? That information is the permissions in Google Cloud. So you need to go to the Google Cloud side and you have a different place to dump. Oh my gosh, that's an admin. Because a Google Drive compromise is very different based on the user. So that's a subtle point that I want to call out is think about the data. You can think about it in stages, bite it off, add in user group role. It'll help a lot. Overall, the approach is going to be start with apps. We're going to count them. We're going to enumerate them to see what's expected, unexpected. Then we're going to refine it based on categorizing what's riskier apps or not. How do we refine it? You look at the permissions they're asking for. So out of a gajillion apps you find, right? Let's assume you're a big moving target because you're in business. You have a lot of users. You have a gajillion apps. You start wanting to classify based on these are the riskiest apps because they ask for sensitive permissions, okay? And then you can ultimately prioritize and remediate by looking at which users are granting access, right? So you have 100,000 things to worry about. Let's see what the top 1% is. You don't have to solve everything today. You're just looking to evolve and iterate, right? So that's the approach we're going to take because this may be very new, right? And so the last thing I'll say on this is, hey, you may have multiple identity providers and resource areas. Start at the most sensitive one. Most of our stuff is in Google. Most of our stuff is in Microsoft. Oh, but second, don't forget about Salesforce. We have contracts and revenue and other things there. But that's second on my list. Start with the top, and for each one, you start to look at different APIs or resources. And I'm giving you this approach so that you can make sense of a lot of things and shrink it down to tangible things. So what I mean is there's 200 different permissions in Google, even if that's your starting point. Well, just focus on Google Drive because, as an example, that may be more important than Google Mail from a data perspective, right? Start at the top and see how much impact you can make. And then you'll iterate and go down the list, right? Assess the app risk, take out the known apps, and focus on the unexpected or unknown, right? That's your job, is to at least classify things as well as shrink that number. Filter it down by permission categories so you have a list of the most risky apps. It doesn't have to be perfect, especially if you're getting started. You just need to start with, this is probably more important, let me focus on this. And then ultimately you're going to trace it back to users. You're going to end up at users because they are the ones granting and creating this mess, but they're also part of the solution of trying to control that. Okay. Now, before we go on to the actual things you can do to reduce this was a lot about analysis and assessment, right? Just get a hold of your apps and permissions and users. It's natural for us, at least for me, you always ask, you want a reason. We're in a blame society. I'm a parent, I blame my kids for everything. It's usually their fault. So we might ask why. How did we get in this state, right? And some of it could be sort of this ignorance. Here's a brilliant quote, right, of it's human to make mistakes, but some people are more human than others, right? It could just be honest mistakes. But really, I think we as an industry, vendors, customers, users, everybody, we've been a little bit asleep at the wheel because OAuth 2.0 has been around for over a decade, and that's led to this. But it started out on the consumer side. A lot of the spec has to deal with consumer-type use cases. And then suddenly it's in the enterprise. That's why I think and we didn't question along the way, is this something we really want to do? Is this something, because I'm not sure there's ever been an example of a consumer-developed technology or a solution that went right into the enterprise with no modification. And to sort of put a nod to some great cinematography, Chevy Chase and Vacation, sleeping at the wheel. That's what I think has happened. To be more specific, you could assess protocols and do a quick assessment of whether you should be cautious or not by looking at its IETF, its RFCs. With OAuth, you start to see it's over a decade old. 2014, they extended it to apply not just authorization, but SSO, which is authentication. Now, OIDC does work if you implement it correctly. And that's a big if, because I will tell you, vendors do their own thing. But just the fact that you're using something designed for authorization, for authentication should be, whoa, pause. Why'd you do that? OAuth is a lot about users delegating their credentials with a subset of permissions. That's not authentication. When you do SSO, you're like, Let me log into Salesforce. Let me not log into another SSO app. But in each case, I have full permissions, and it's me. OAuth is delegating that to an app for automation. It doesn't make sense at the high level, and it definitely doesn't make sense because we have different abuses and attacks. 2019, we extended OAuth, among other reasons, to handle smart TVs, limited input. I'm not saying that couldn't be a good use case. I'm saying if you think about the timeline, 2019 is 12 years after the iPhone's developed. I think the iPhone 10 is out. I think we have many rich devices that could allow us to authenticate Netflix to our TV better, easier, safer. There are well-known published, look up Dr. Azure AD, Dr. Nestori. He has done a lot of work about Microsoft phishing using device code flows, which is a part of OAuth, designed for dumb TVs. I'm saying at the high level, this is why we're in this mess. SSO continues on, but people customize OAuth. Microsoft does a customized version. They don't use OIDC. They allow device code flow. They do weird things. Google does it too. AWS doesn't use OAuth except in SSO. That was a surprise to me because AWS wasn't part of the presentation, but now I have an excuse to make fun of them. The maze is all the RFCs. I didn't create that. Some smart person at Okta has referenced that, and they do know what they're talking about when it comes to OAuth. And they're making sort of light of the complexity. How many RFCs does it take to change an OAuth light bulb? And it's basically this idea that with too many use cases, often some of them useless, refrigerator being a toaster, everything in the kitchen sink, the usual stuff that comes from developers. So how do we get out of this mess? Okay, let me translate this 10-word quote into something clear. Lower your standards. Don't shoot for happiness. Just try to be a little less sad. Come on, you've been dealing with this your whole career in cybersecurity. I know you have. Without being full of despair, we do have to be practical. There aren't any shortcuts. Poor Schaeffer Trucking will live on forever on the internet. Whatever you do, don't boast about what you can do to solve it, like they did with all the slogans. Practically speaking, we're going to go around some of the areas in security ops. We talked a bit about initial inventory and analysis. So let's talk about control areas like prevention, detection, and remediation. And I want to say something quick. We have about 7 minutes for me to accelerate and get this important stuff covered. We've been talking a lot about inventory analysis, which helps you with sort of normal activity by your users, whatnot, sort of things that you should expect, not necessarily malicious targeted abuse and attacks. However, everything here needs to be in place for you to get a handle on the advanced phishing that can be done with Microsoft using device code. There's a general phishing attack in the OAuth world called illicit consent grants. You create a fake OAuth app. You convince a user. It's called O365. I pretend to be Microsoft Office 365. I ask for permissions, sometimes extra permissions. I get them to hit the OK on that dialog box that they never looked at. Now I've got their token. And away I go. And part of that dirty secret of the abuse side is OAuth says they're a temporary token system, and it's really permanent in almost every single implementation. I can keep refreshing and getting access as an app vendor or as an attacker. Sometimes you can change a control on your side to time out, but for the most part, it's permanent. So it's sort of like saying, I'm secure through obscurity. You don't have the code to my bit shifting UU decode crypto algorithm. It must be safe, right? No, of course not. Just because, in this other case, the OAuth world sometimes says that sort of too much. You have to be aware of that. Okay. So let's talk about things. The inventory, which we covered, just remember, get the right data. You can start easy with console. Start with audit logs and approvals. But don't forget about user groups and roles, which might be on the resource provider side. You can do APIs, but you can also do console export. Assess the risk. Go through that sort of loose framework that I mentioned. Focus on unexpected outliers. Try to reduce the number of risky apps. Now let's talk about things that are new, actual prevention controls. There are two things that I'll pull out that should be done. Almost every vendor has a version, they're not consistent. One has to do with this whole approval process. You've got this mess of access paths, so let's reduce that, at least going forward, by controlling the approval process. By default, a lot of times the user's in control, remove that. Either the admin does it all by pre-installing, pre-approving corporate standards only, or you're in the middle and users approve, but it goes to an admin for final approval. You figure out what you can do as a security organization, overhead cost, but you put something in place so that users just don't create endless work for you, right? You got 10,000 apps every month. Shrink that down so you can deal with the current mess and not have it grow bigger. Session timeouts. This is more of a mitigation procedure. You have access paths in place, someone compromises it, bad app, bad actor, something, phishing attack, time out the token and cause the app to re-authenticate, ask the user again to type in their credentials. It is a mitigation procedure against compromised credentials, which is where these access paths could lead to, right? So we're sort of moving from access to exploitation of that access and how you deal with it. But I put it under prevention. And so these are screenshots of where in Google you can find these settings, but you look at every vendor and see what their version is. Every vendor is slightly different. The SaaS vendors tend to be better, by the way, than Google or Microsoft. You look at Salesforce, they tend to be a lot tighter. You look at Dropbox or Box, they tend to be a lot tighter and more functional. Detection measures. So you're compromised. We've moved past the access control and you're dealing with an incident. So if you get a hold of what's allowed in your app list, part of what you could do is detect it afterwards. You might not have prevented it or you're working on it because that might piss off some people, but you can certainly detect off of it. I know these are 50 corporate apps. Anything that doesn't match, at least someone will get notified and they can go assess it. Quick response may be just as good as prevention. There is an area that you can't control but you should look at, and that'll be behavioral detection. At the end, the bad effects will be compromised credentials accessed along these access paths. Microsoft, as part of Cloud Defender, has a couple use cases that look at OAuth abuse detection in the ML type area. You just track that, you use it, you test it. More will be coming. It's inevitable because that's the only way you can deal with the after effects. You do want to periodically audit app connections or app approvals because some of these apps may never actually be used after the initial approval. And so age them out, delete them, right? There's ways to actually delete these app approvals after the fact. And then remediation needs a few words. The bottom line here is if you're dealing with an incident and access has been compromised over these access paths, you need to revoke that access. And because it's OAuth underneath, the thing to remember is there's two OAuth tokens. One's the actual access token, the one's the refresh, where I can get permanent access by every hour getting a new token. Both need to be revoked. The vendors would give you an API or console feature to do that. Microsoft, for example, gives you an API to revoke the refresh token, but not the access token. And their documentation acknowledges this and says, wait an hour. Wait an hour while I'm in the middle of an incident, right? It's really dumb. But you need to be aware of this, adjust your procedures so you have a clean revocation process. So I guess to wrap up in the sort of final minute, if this seemed relevant, what I would suggest is taking baby steps. Sort of in the next week or right after, think about assigning ownership. Maybe that's you. Maybe you have someone on your team to look into this, to go over the material to see if it still makes sense, and reach out to me for clarifications. And if so, you can do simple things like export some audit log data and throw it in a spreadsheet, and in half an hour, just do some counts and just see if anything seems big, small, ugly, good, bad. And if that turns into a useful exercise, then in the following weeks, you can start to assess the risk there better by looking at outliers and unexpected apps and risky app categories. You can start classifying, filtering, and sorting in that same spreadsheet. And again, if that makes sense, and this is providing value, then you start looking at actual controls to reduce what you've found. And that becomes your simple process for saying, great, next quarter we'll repeat the process. Hopefully some of the controls will shrink it, or next month. If you've already done this, pat yourself on the back. You're right, that's the 0.1%. And really, what you want to do is start focusing on the abuse. What is innocent user action versus what could be a phishing attack? And so you're going to build on top of the app inventory. And you're going to do things like implement a testing process. Again, this is step 3 or 4, not step 1. What I would do for any new app, that whether it's a corporate app or a user app, whatever you allow, is when it's first installed, I would go look in the audit log and see what its ID is and what its name is. And I would say, those two I know is the Zoom client on Mac OS. This other one is the Zoom client on Windows. This other one is the one on iOS. We accept them all. When I see them in the logs, I know it's not a threat. I've dealt with it. But in the future, maybe you see a Zoom client with a weird ID. You'll be like, whoa, what is that? I got an alert through my SIM. Didn't match. Is it malicious or is it a new version? Could be either, but you'll be better off. That's what I would focus on if you're more at the advanced stage, is really being refined and knowing what's expected or not. So I think I'm 1 minute over. We don't necessarily have time for questions, but I will be in the hallway. If you do want to follow up, I have a Birds of Feather at 2:25, same subject, that you can attend, or just reach out, contact information. I'm happy to always respond and talk about this. Thank you so much.